People inside Eli Lilly's clinical trials for Retatrutide are reporting something remarkable: dramatic appetite suppression, unlike anything they've ever experienced on other medications. So, why are people using gray market Retatrutide reporting almost none of that? They're burning fat, their metabolism is up, but the hunger is still there. And why are so many of them quietly adding tirzepatide back in just to feel full? I think that is because I do not believe they are the same exact drug. That isn't to say that people aren't seeing real, meaningful results on gray market Retta. I think it's just that they are different formulations. Fair warning before we get into this: I am not a mad scientist. I am not a rogue chemist mixing things in my basement. I'm just someone who reads too much and asks too many questions. So take everything I'm about to say as my best informed opinion, not a medical lecture. That said, I think the data backs me up. Let's get into this. Now, before we get into the problem, let's understand what retatrutide is supposed to do. And I'll try to explain this in a way that doesn't make both of us fall asleep. Retatrutide, developed by Eli Lilly, is a triple hormone receptor agonist. Fancy words, I know. Here's what that means in plain English. Its design ensures that while all three receptors are engaged, a predominant effect at the GIP receptor yields robust improvements in metabolic control, and this triagonism results in a synergistic effect across multiple metabolic pathways, integrating signals that reduce appetite, enhance insulin sensitivity, and promote energy expenditure, all at the same exact time. That's three receptors with three different jobs, and critically, they all work together in a very specific ratio that Eli Lilly spent years engineering. GLP-1 receptor activation is the established mechanism for decreasing appetite and food consumption. Glucagon receptor activation raises resting energy expenditure and drives fat burning. And when GIP and GLP-1 work together, they promote improved appetite control and delayed gastric emptying. The last part, GIP and GLP-1 working together, is everything. It's exactly what I think the gray market is getting wrong. Let's look at what pharmaceutical grade retatrutide actually does to appetite when it's made correctly by people who actually know what they're doing, unlike me, but very much like Eli Lilly. In the landmark phase 2 trial published in the New England Journal of Medicine, at 48 weeks, participants saw weight reductions of 22.8% at the 8 milligram dose and 24.2% at the 12 milligram dose, compared to just 2.1% in the placebo group. But beyond the weight numbers, the appetite data is what I want you to focus on. Participants who received retatrutide at 4 milligrams or higher reported significantly greater reductions in overall appetite, hunger, and prospective food consumption compared to placebo. And these differences were statistically significant at 24 weeks. And in the phase 3 TRIUMPH-4 trial, decreased appetite was formally documented as a significant adverse event occurring in roughly 18 to 19% of retatrutide participants at the highest doses, compared to only 9.4% in the placebo group. Across both studied doses in TRIUMPH-4, decreased appetite was consistently listed among the most common adverse events, more frequent with retatrutide than placebo at every dose level, and consistent with what the broader incretin drug class produces. The phase 2 appetite data goes even deeper. Using a validated appetite visual analog scale, which is a clinical tool that measures hunger, fullness, and food cravings on a scored spectrum, participants receiving retatrutide at 4 milligrams or higher reported significantly greater reductions in overall appetite, hunger, and prospective food consumptions compared to placebo at 24 weeks. Critically, improvements in perceived hunger and disinhibited eating behaviors were also greater with retatrutide than placebo, meaning participants weren't just eating less, they were fundamentally experiencing food differently. And at the highest dose, 12 milligrams, the clinical picture becomes even more striking. Trial participants at that level reported what researchers described as near complete appetite suppression, extended periods without hunger signals at all, not reduced hunger, not manageable hunger. The hunger simply was not there. That is what the correct formulation hitting the right receptors in the right ratio actually does. Real, measurable, peer reviewed appetite suppression. So, why aren't gray market users getting this? Here's the pattern showing up consistently across forums, communities, patient groups, and folks that I've talked to that are on gray market retatrutide. Fat burn, yes, they're getting that. Elevated metabolism, they're also getting that. Body composition changes, they're getting that as well. But appetite suppression, almost nothing. And the most telling behavior, the thing that made me go down this rabbit hole, is that a significant number of gray market retatrutide users are adding tirzepatide, either in the form of Zepbound, compound, or gray market itself, specifically to get appetite suppression that retatrutide is not delivering. Think about what that means. They're paying for a triple agonist and then buying a second drug on top of that to feel full. That is not a coincidence. That is a clue. And in my completely non-scientist, just a person with internet access and an opinion, it points directly to one specific failure in the gray market formulation. Okay, here's where my non-chemist brain comes in handy, because I think the best way to explain this has nothing to do with molecules. Imagine I give you everything you need to bake chocolate chip cookies: flour, sugar, butter, eggs, chocolate chips, baking soda, salt, vanilla extract, all the ingredients, every single one. I didn't leave anything out. But I didn't give you the recipe, no measurements, no ratios, no instructions on temperature or timing. You still have chocolate chip cookies, at least technically. All the right stuff is in there, but without the measurements, the ratio is off. Too much flour, not enough sugar. They come out wrong. They don't hold together. They don't taste like the ones you were expecting. Now, here's the part that I think is key. The glucagon component of retatrutide, the part responsible for fat burn and increased metabolism, that's your chocolate chips. Hard to miss, easy to include, and gray market users are clearly getting it because they are seeing fat burn and metabolic changes. What's off is the flour to sugar ratio, the GLP-1 to GIP balance, the precise relationship between those two receptors that creates appetite suppression. And without Eli Lilly's proprietary recipe, which is not in the patent, we'll get into that. Gray market manufacturers are guessing at that ratio, and based on what users are reporting, they're guessing wrong. Okay, this is where it gets a little sciencey, and I want to remind you, I'm just a person with a curiosity and a Wi-Fi connection. But stay with me because I think this is where it all clicks. To understand why the GLP-1 and the GIP ratio matter so much, you need to understand what tirzepatide, which is mounjaro or Zepbound, actually is under the hood. Because here's something most people don't know. Tirzepatide doesn't treat GLP-1 and GIP equally. It's deliberately, intentionally imbalanced. Tirzepatide was discovered by engineering GLP-1 activity into the GIP sequence. It is an imbalanced dual agonist in favor of GIP over GLP-1, showing equal affinity for the GIP receptor compared with native GIP, but binding the GLP-1 receptor with approximately five-fold weaker affinity than the native GLP. So it's actually a GIP more than it is a GLP-1 drug. And this imbalance isn't a mistake, it's the whole point. The imbalanced nature of tirzepatide may be critical to maximizing efficiency because dose escalation for GLP-1 receptor activation is limited by gastrointestinal side effects like nausea, while GIP receptor engagement is not known to cause similar issues. So what Lilly figured out with tirzepatide and then carried into retatrutide is that GIP is the amplifier. It takes the GLP-1 appetite signal and supercharges it. More hunger reduction than GLP-1 alone could ever deliver, with better tolerability at higher doses. Retatrutide is built on the same principle with glucagon added on top. It's designed to ensure a predominant effect at the GIP receptor, meaning the GIP to GLP-1 ratio inside of retatrutide is just as precise and deliberate as in tirzepatide, maybe more so, because now it has to work in concert with a third receptor. Without that exact ratio, the GIP can't amplify the GLP-1 signal properly. The appetite suppression mechanism falls apart, and you're left with something that burns fat because glucagon is doing its job just fine, but doesn't touch hunger the way it's designed to. Again, this is my read on it. I'm not peer reviewed, but I think the logic holds up. So where does the gray market go wrong? Right here. And this part I find genuinely fascinating. Eli Lilly's patent filings are public documents. Anyone can pull them up, and those filings do disclose the active peptide structure, the amino and acid sequence, the receptor targets, and some of the inactive ingredients. The ingredients are listed right there, public record. What's not in the patent is the proprietary formulation, the exact buffer system, the pH, the stabilization chemistry, and most critically, the precise receptor activity ratios that Lilly spent years in research dialing in. Great market manufacturers can synthesize the peptide. They can likely get the amino acid sequence right, but they are guessing at the ratios. They don't know whether the GLP-1 receptor activity is hitting the right potency relative to GIP. They don't know if the molecule's affinity balance matches what Lilly engineered. And as we just covered, that balance is everything for appetite suppression. The chocolate chips are in the cookie, the glucagon is working, but the recipe for the specific GLP-1 and GIP interaction that drives appetite suppression, that's still locked in Lilly's lab, not in any patent, not available to anyone making gray market retatrutide. That is my best guess as to why, and I think it's a pretty solid one. Now, here's the part that to me ties the whole thing together, and this is where my non-scientist brain actually thinks it figured something out. The drug that gray market retatrutide users are reaching for to compensate, tirzepatide, is a properly formulated FDA-approved drug with a known deliberate GIP-dominant receptor profile. When they add it, they are, without necessarily realizing it, patching in the precise GIP amplified GLP-1 signaling that their gray market retatrutide is failing to deliver. They already have glucagon activity from the retatrutide. Fat burn, check. Metabolism, check. What they're missing is the GLP-1 and GIP synergy, and the tirzepatide fills exactly that gap. You could not design a more elegant natural experiment if you tried. The drug people are reaching for to fix what's missing is the exact drug that would fix a broken GLP-1 GIP ratio. That's not random. That tells you precisely where the gray market formulation is coming up short. At least that's how I see it. And I think it's hard to argue with that. Look, I could be completely wrong about this. I'm not a pharmacologist. I have never run a clinical trial. I'm not mixing anything in my garage. This is my best guess based on publicly available science and what I'm observing in the community. But when the pieces line up this neatly, clinical trial users reporting strong appetite suppression, gray market users reporting almost none, and those same gray market users instinctively reaching for tirzepatide to fill the gap, is hard to argue. The data on pharmaceutical grade retatrutide is genuinely exciting. It's just got more exciting. In the phase 2 trial that started all of this, participants at the highest dose achieved a mean weight reduction of 24.2%, which is about 58 pounds over roughly 11 months. That alone was remarkable, but then the phase 3 results started coming in. In Triumph 1, the pivotal phase 3 trial, results of which were just announced on May 21st, participants on the 12 milligram dose lost an average of 70.3 pounds, representing 28.3% of their body weight over 80 weeks. And nearly half of the participants, 45.3%, achieved 30% or greater weight loss, a level historically associated with bariatric surgery. With real documented appetite suppression baked into every one of those numbers, that is what a precisely formulated, properly engineered triple agonist does when the recipe is right. All the ingredients in the world won't bake that cookie without the measurements. If this resonated with you, share it with someone who's been asking why their retatrutide isn't working the way they thought it was. And if you think I'm totally off base, tell me in the comments. I genuinely want to know. And if you're watching on the app, please hit that hype button. I'll link the phase 2 NEJM study, the TRIUMPH-4 and TRIUMPH-1 phase 3 data, and the tirzepatide receptor paper in the description of this video. Talk to you next time.